Hi, everybody, and welcome to the SDSU Center for Autism Research Spotlight. We're here to highlight some of the wonderful research that's being conducted here at San Diego State by our center members. And we're continuing to take advantage of these stay-at-home orders during this COVID-19 pandemic to showcase the work that our center is doing in the San Diego autism community. My name is Janice Chan, the Administrative Coordinator at the center.
And my name is Vinton Omaleki. I'm the Community Engagement Director here at the center. Today we are speaking with Dr. Ina Fishman. She is a Research Associate Professor in the Department of Psychology at San Diego State University and the founding member and the founding director of the SDSU Center for Autism. Thank you so much, Dr. Fishman, for taking the time to speak with us.
Of course, I'm very happy to be here.
So before we get into the nuts and bolts of your research, would you mind just telling us a little bit about the SDSU Center for Autism?
Happy to do so. As some of you know, a few years ago, I'm sure I was not the only one, but I personally realized that there is so much talent and cutting edge work that happens at SDSU related to people with autism and with other disorders of development that was not, that did not have a house, did not have a home, and we were not sort of united and organized and perhaps not always communicating about research that could benefit some of our work and efforts. And I'll give you examples. SDSU is a large academic center, as many of you know, and we have scientists and clinicians and clinical scientists representing a very diverse fields of inquiry and academic pursuit, including psychology, basic neuroscience, language and communication disorders, social work, implementation and dissemination sciences, and those are just a few that are available to me right now on a moment notice. And we existed in different colleges and in different labs, and I think as a psychologist, as somebody who interacts with people on the spectrum, it's always useful both for scientists and researchers and very much so for families when the information exists in some kind of integrated way under one roof in a hub, which is really what I was looking for SDSU to have. Not unlike other centers across the countries that I was aware of, in which people who work with individuals or on topics that are relevant to people with autism sort of like have a center where they can share ideas, exchange information, and deliver that information to the community. So this is a long-winded answer, but I really wanted to have a center that will unite at that point diverse researchers that all have shared goals in mind. And I hope now we have that. We're still growing. I've been telling my colleagues and friends that I believe, moved from an infancy to a toddlerhood stage in a sense of being a little more coherent and really building relationships among us, which just like with any development, whether it's child development or organizational development, it's a work in progress. But I've been learning a lot from my colleagues just in the last year or two. So I think it's been wonderful. And so again, this may be a long answer, but to try to put it in a one sentence, I think our center basically is what I would call a home for diverse scientists and clinicians, all of which work from very different fields and perspectives, again, either with or for people on the spectrum to try to either help clinically or develop future interventions that may become, a way of the future, if not cure, then help to people and families of people on the spectrum.
That's great. And I think it would be really interesting to our viewers at some point for you to really share more about, you know, the center, what your vision is, what you hope for it to, where you hope for it to go. I think a lot of people from my interactions at least, a lot of people are very interested in the role that San Diego State can play in advancing research and implementation and innovation with regards to autism. So maybe another time we can have you share even more about that.
Yeah, thank you, Janice. I must add some. I actually am sitting not at home, but at our center, just because I had sort of work to do in the office today. And just behind me, it is just one example. You reminded me how crucial really and central to our goal and mission is the ties with the community. And just behind me is just one small example of what we do and what we were able to achieve in the last couple of years, very much so with the help of these two individuals here. So behind me is just one piece of work by an artist on the spectrum, and it represents, I wish I could turn around and show you many works of arts that are exhibited now in our center on loan to us by people on the spectrum from San Diego community. And there are wonderful, amazing works of art. So that's just one sort of connection that we serve as a safe gallery or a home where people can come and present their work of art. We, I think both of you guys know that 2 summers ago, maybe a summer ago, we had a music and autism art festival where people with different types of talents, with amazing talents in performing arts, were able to sort of present their work open to all San Diego State and San Diego community. Those are just 2 examples of events that people may not realize that we hold for the community. So I should probably mention that among our missions, among our goals is of course to conduct state-of-the-art research, but also to give back and have communication with the community in terms of delivering the right type of information about what research means and what scientific advances are taking place, and also providing sort of like a safe place for people to either seek information or present their talents.
That's awesome. You've mentioned a few times throughout in the last few minutes about research and the amazing research that's being done by many of your colleagues at San Diego State. For you specifically, what kind of research do you focus on?
Yeah, I always prepare people when I describe myself. It's a long-winded answer. I'm a clinical developmental neuroscientist. And
okay, what does that mean?
What I mean by that is I'm a clinical psychologist by training and by trade, really. I still sort of provide evaluations and diagnosis to people on the spectrum, which means I understand and am trained, and my expertise is in sort of like clinical expression of human nature, whether it's autism or typical development or else. But I also do enjoy and conduct developmental and cognitive neuroscience research. I use neuroimaging methods, a variety of them over my relatively short career. I'll give you examples. I use tools that allow us to peer inside the brain of living individuals. In my graduate school, I used EEG and electroencephalography to sort of like understand brain dynamics and in which order our brains process information. More recently at SDSU, I used magnetic resonance imaging techniques, which allow us to take pictures of the brain, and those pictures can also be videos. They could be still pictures, they could be like videos that allow us to look or brain dynamics while people think, feel, exercise their mind, and this can be used, applied safely with children and adults and very young children, as I'll be able to tell you in a few minutes. so the tools of scientific inquiry are what make me a neuroscientist, and I think the clinical and developmental are very necessary descriptors in my discipline, because they sort of like capture how I view individuals. I always am interested in sort of developmental stage of where people are, and that's a crucial component, as you know, of autism spectrum disorder. And in terms of my sort of clinical training, I enjoy exercising that when I'm speaking with families and working with kids on the spectrum.
Awesome. And so tell us a little bit about your current research study.
Very happy to do so. So for the last few years, it has been, I'm not unique in that sense, just like everybody else, I'm interrupted by the pandemic. But before the pandemic, for the last 4 or 5 years, I've been leading a very exciting study with very young kids on the spectrum. Just as a very short background, I hope many of the people that tune in today know that unfortunately we still do not have any biological or brain markers of autism, right? We unfortunately diagnose and detect autism with behavioral tools, meaning looking at somebody's behavior, talking to their parents or teachers or an individual themselves. Yet everybody understands that, or the consensus it is, and the strict medical definitions are such that autism is a disorder of brain development. So I, like many others, we are trying to understand what is it exactly in brain maturation or development or function unique in people on the spectrum. Why do we need that information? So that we can become eventually more targeted and more specific with our interventions, right? So you want to target them to specific circuits that one day will know what they are. For the last decade or so, people, including myself, really have been studying this in school-age children. Why did we do that? Because, by age of 6 or 7, it perhaps is a little easier to convince somebody to lie in the scanner and to follow instructions, and for us to obtain quality brain imaging data from MRI scans, from which we could perhaps learn about their brain structure or the way different brain regions are connected, and perhaps look for signs that discriminate between kids on the spectrum or not. And I was one of the people who have worked very hard on that sort of research pipeline. But after a decade of research studies, we've actually learned that I use this colloquial expression that autism is nowhere particular in the brain and everywhere in the brain, right? So we have learned that it's not a specific brain structure or a specific brain system that is different in children on the spectrum, but that there is this overall organization that appears to look different in very subtle ways, None is striking and concerning to a neuroradiologist, for instance. However, people began asking, okay, but knowing that in middle childhood or in late childhood, what does it tell us about the causes or the etiology or the way the autism develops? Because we know that autism symptoms manifest very early on. I used to say, in the first years of life. Now we very confidently say in the first or second years of life, you can reliably diagnose somebody with autism. But if we can't sort of hear inside the brain at the same time when the symptoms first emerge and manifest, then what good does it tell us to know how a child's brain look when they're 6 or 7 years old, when they have had a chance of, experiencing the environment and the individual or in personal interactions differently than others, if we assume that that's indeed sort of what characterizes people on the spectrum, that they have different way of interacting with others and perceiving social information from others. So in a way, it is way harder to conclude something about the causality or etiology or the ways autism emerges from data that is collected later in childhood, not to mention later in adolescence or in young adulthood. So the field has been pushing towards, let's see what we can do with these young kids. And luckily, I think back in the 90s, people were actually scanning sleeping infants or toddlers under sedation. We have moved on since then. Luckily, again, I stand on shoulders of giants who have developed safe methods of scanning very, very young kids, infants and toddlers, without any invasive protocols, without any medications, no sedation, just basically by sitting, twiddling our thumbs and waiting until they fall asleep naturally, as they naturally do every night. Now, many of my colleagues know it's not as easy and it takes time, and it's really just almost a random event whether one will fall asleep on time or not. However, children sleep, we all spend time in sleep at night. And so we scan our very, very young kids under the study that I'm taking so long to describe to you, when they show first clinical signs of autism. So we, back a few years ago, started recruiting across, a broad and wide San Diego County and beyond, from my colleagues and partners at Radius Children, at UCSD, at many other clinics, or ABA facilities, or early childhood centers. We were looking for really very young kids who, based on sort of specialized clinicians or clinician specialists, show first sign of autism. And at that point, we recruited these kids. We characterized them behaviorally and cognitively and socially. We put them through a battery of age-appropriate, play-based activities and tests. And we also discussed with families how we can make this more likely that a child will fall asleep in a large sort of like research center where the MRI machine is housed. And we developed a very sophisticated, I would say, strategy that is very individualized for every family, for every child, where we developed a really child-specific plan in terms of how we're gonna increase our chances of this child falling asleep in the scanner. Should they bring their favorite blanket? What time they go to sleep? Can a parent carry them from a car if they are asleep already without waking them up, and so forth? I mean, there are, I think, more than 20 or 30 questions that create this habit almost picture for every child. And we try to target our setting and the light and the number of people that will meet the family, so that, again, we can optimize the chances that the child will fall or remain asleep in the scanner. And the goal was to scan them when they're a year and a half, maybe 18 months. And it is a longitudinal study funded by the National Institutes of Mental Health that allow us to look at the same indices, behavioral and brain indices, as these children grow older. So as they reach school entry age. So the study follows up these children between the ages of 18 months to about 5 years of age, which, as I said, has recently been interrupted by the pandemic, sort of the last wave of scans and behavioral testing. But you probably want to know what is it that we are gaining, or what knowledge have we been able to get from this very, very, very time-consuming sort of type of research. First of all, it's very gratifying to work with young kids and with their family. Very gratifying, and I think all the students and staff and employees really enjoy this type of research. And I have worked myself with adults and other kids of other age, so it's not like it's not enjoyable to speak to another adult. But there's something about being able to play with young kids and actually seeing them from one appointment to another, and seeing an amazing gains in some children, whether as a result of plain maturation or hopefully as a result of early interventions, which is a lot of our children are enrolled in, has been really gratifying and I think very informative for future clinicians that are involved in the study. And from the point of view of the actual study goals and aims, which is what we wanted to understand, how early and when can we see differences between the brains of young children with and without autism? So I can tell you the answer. We can see that very, very early. Again, as early as 15 or 18 months. What is it that we're seeing? We're actually seeing things that are looking sort of, as always, hindsight is 20/20. Looking back is now very intuitive. If any of you are parents or know anything about sort of early childhood development, you know that the first couple years of life are predominantly devoted in terms of brain and behavioral development to sort of basic sensory motor skills. And what I mean by that, if you recall your child being an infant, first they learn how to walk or how to sit, how to pull themselves up, how to walk. This is all called motor skills development. They also, the ability to see, hear, and feel is being fine-tuned during these first years of life before a child can actually devote the next sort of the next few years to developing language and starting to interact with others, right? And so, not surprisingly, it is within this domain of sensory processing that we found the biggest differences between the kids on the spectrum and not. And what I mean by that, when we looked at the brains as a group of children who have symptoms of autism and those who do not, typically developing kids, we found very sort of robust differences in the way their brain regions that are devoted to processing sensory information are connected. And they're actually connected with more, if you will, or with more intense strength, if that makes sense. So as if there are brain regions that, or brain networks or brain circuits that have to do with processing sensory information, whether it's visual information coming from the back of the brain or auditory information or somatosensory information that helps us to develop motor skills. All these regions were overly or more so connected in these children, which whenever sort of like people hear overly or greater connectivity, it sounds like a positive aspect of development, right? More perhaps in many people elicits better. However, remember all the comparisons that, or any really knowledge that we have about brains of children or adults with autism, only as good as our comparison to a typical development, because we don't have any other gold standard. Like there's nothing about brain science or neuroscience that provides us with markers. Like when you go to a pediatrician visit, they tell you, oh, your child's height or weight is within 50th percentile. I mean, they're thriving well. We don't have anything like that for brain activity, which is you can take either way you want. After decades of research, we still sort of don't have the absolute numbers, right, to which to compare. And I say that because just to remind you that, again, any inferences that we make and that we found in our study are in relation to what we can see in a group of children that appear to be typically developing and don't have any signs of autism. So in their brains, the connections between these different sort of sensory regions are, of course, exist, but they're sort of like at a lower level, at a much lower level than in children with autism who have these connections kind of heightened. And the interpretation that we find for this is that, of course, autism begins earlier than 18-month-old. It begins prenatally. We actually sort of know that from other more basic neurobiology research. And so whatever very early prenatal developmental abnormalities took place, they give rise to what we can see by age 18 months as this disorganization in circuits that are relevant to that developmental stage. Remember, I said this is what a child does in the first or second year of life. They kind of develop their motor and sensory skills. And so at that point, these connections appear to be, hyper elevated in these children. And so what when I try to explain this to parents or to other sort of like scientist colleagues, the implication of that is that their brain perhaps has less resources to devote to the next stage of development. And we see that or I guess the evidence to support this is that indeed this level of higher or greater connectivity corresponds to the level of their autism symptoms from what we can tell. And we really look forward to, if we can or when we can, to seeing this longitudinally in these children, which means the best scientific evidence in terms of development comes when you're able to collect the same information in the same individual more than once. And so we want to see what happens when these children grow, when their symptoms perhaps improve, as we've seen with many, many kids in our cohort, as I said, because I think of the early interventions. We want to see if these connections normalize perhaps, or perhaps they, continue to disrupt the next level of brain maturation and development that is on board.
That's fascinating.
Yeah.
So Dr. Fishman, you were saying that the center and a lot of the research right now is technically paused, but if parents are interested to kind of get on a wait list, or at least whenever the center and the research starts again, they can be inducted into the study.
Yeah.
Who do they reach out to?
Yeah, I'm glad you brought it up because that brings me back to reality. And I don't know if you guys know, today is August 25th. I think we're doing better in San Diego. Or maybe I'm just being hopeful, but I hope we're, approaching the stage where we're able to be back to in-person activities and welcome the families back. Before that or prior to that, the families are, welcome to keep in touch with our coordinator. I'm gonna hope that you guys sort of put the right information at the end of this talk or in an accompanying Facebook post. But as Vinton knows, we actually have been in touch with all of our families in the beginning just to see how they're doing. While when we understood this is going to take a while, we started offering resources in terms of what's available in San Diego and online virtually, either to keep these kids, receiving some interventions through telehealth, or just at some point we started providing resources and support to parents themselves. And it's funny. I am a parent myself, so I'm seeing myself as a parent through all these stages of the pandemic as well. First you wanted to help the kids, you just looked for any resources. At some point, if you recall, there were so many resources, we were all overwhelmed with the amount of stuff that we can do online. And at some point, I know our staff, in the beginning of the summer, we realized that we need to provide support to the parents themselves. We started asking them how they're doing. And many of the parents, write and email us back. So it's been very gratifying to sort of hear from the families how they're doing or whether our communication has been of help. So we have kept in touch. As you know, you continued providing a lot of our talks and workshops online, which I think was also a big support to many families, especially to, families who are first-time parents of, that maybe it was probably particularly hard on them. So I feel like we've remained in touch, and the families can continue, being in touch with our coordinator, which I'm sure you'll put up the email and the phone number that they can reach us to.
Yeah, we'll definitely make sure we provide that info.
Great.
Yeah, and then, so this is great. This was really interesting. I mean, like personally, I've worked with you for, a year now and didn't know all the details of everything and the really groundbreaking work that you're doing with regards to neurobiology and autism. If people are interested in learning any more about this topic, where would you recommend them going? I'm a little afraid that, and I think that's probably the case in every field. There's a lot of information online. And I remember, again, as one of the missions of our center was to provide sort of like to weed through
the weeds for the families and members of the community, and to provide them with what we deem as useful and accurate information. So I believe there are a lot of resources on our the center website, but in terms of early childhood development, there are so many great resources online, and I would first and foremost go to sort of like well-established organizations and sources like Autism Speaks and Autism Science Foundation. They both have pages and pages devoted to parents and early childhood development and signs that parents should look at. And I think, as we've discussed a little earlier, there's this amazing resource that I became aware of recently. It's called Autism Navigator, I believe. And I think they also have a specifically baby navigator and toddler navigator. It's a great resource for families with great visual information with pictures and videos of what are these first milestones and signs that parents should keep an eye on in the first years of life, because they may, some of them may be red flags for to look perhaps for an evaluation and initiation of early intervention. I believe currently the consensus is, and I hope many sort of educators and parents and families encounter that in the community, is that the labels currently do not matter as much. So I think people for instance, in the regional center in San Diego or in early education are not afraid to what would be considered overdiagnosing somebody who is an 18-month-old, as long as that provides them an entry into the world of early intervention. Early intervention cannot hurt, really. It cannot hurt. So even if this was an overdiagnosis, a misdiagnosis, and if the child does not have autism, the behavioral benefits of early interventions are, really overreaching. So I think the resources that I've mentioned, I think sort of err on that side of, be aware of what are the signs of typical development and atypical signs. And if you see anything, seek help. I think that's kind of the message that I would like to spread out.
Great.
Awesome. Well, thank you so much, Dr. Fishman, for sharing your expertise with our community. We really appreciate your time and the impact you're making in autism research at the center and in San Diego, broadly speaking. So for those of you who are watching, if you want to learn more about the center and our center members, you can find us at autism.sdsu.edu.
Or you can also find us on Facebook, Instagram, and Twitter, where our handle is at SDSU Autism. And we'll see you next time for our next Research Spotlight. Take care, everybody.
Thank you. Stay safe, everybody.